Hello, grade 8. In this video, I'm going to answer with you exercise 2.4, distance time graphs from your workbooks from pages 14 to 16. Okay, in this exercise, you draw and interpret some distance time graphs. You can calculate the speed of an object from the gradient or slope of the graph. A. The diagrams A to D show distance time graphs for 4 moving objects. Complete the table by indicating in the second column the graph or graphs that represent the motion described in the first column. So let's look at these graphs. They represent parts of a journey for different objects. The graph line in this graph, graph A, is straight and horizontal. The graph line in graph B, it's also straight, but it's sloping upwards. The graph line in C is curved downwards, and the graph line in D is straight and sloping upwards. Remember that a straight line, flat or horizontal, represents a stationary movement on distance time graphs. Straight sloping upwards describes a steady speed. Curved line describes a changing speed. If it's curved upwards, this means that the speed is increasing. If it's curved downwards, this means that the speed is decreasing. So, description of motion, moving at a steady speed. So, the line must be straight and sloping upwards. So, B and D. Stationary, not moving. This means that the graph line needs to be straight and horizontal. This is graph A. Moving fastest. Now, which two graphs we can compare their speeds? B and D. In B and D, they are both traveling at a steady speed. The line graph in B is steeper than D, so B is faster than D. So B is moving the fastest in all of these graphs. Changing speed, we said that the curved line represents a changing speed. So C. B. The table shows the distance traveled by a runner during a 100-meter race. Use the data to draw a distance time graph on the graph paper grid below. So first I have to study the table to know how I am going to divide my x and y axes. The distance traveled, 0 at 0 seconds, 10 meters at 2 seconds, 25 meters at 4 seconds, 45 meters at 6 seconds, 65 meters at 8 seconds, 85 meters at 10 seconds, and 105 meters at 12 seconds. So, the race lasted for 12 seconds, and the distance range was from 0 to 105. It's a 100-meter race, so he traveled an extra 5 meters. Now, time should be labeled on the x-axis, time in seconds, and the distance on the y-axis, distance in meters. Okay, how am I going to divide my axes? Remember that I need to use more than half of the graph paper that I'm given. The time now is divided in twos, so I have to divide it in twos. But how am I going to divide it? If I use two grids, so here's 0, 2, I will provide a copy of the work so that you can look at it at a closer distance. 4, 6, 8, 10, and 12. Here I used more than half of the graph paper. I used two grids for my divisions. And how am I going to divide the distance axis or the y-axis? It has to range from 0 to about 100, 105. So I need to also divide it into 20s. 20, 40, 60, 80, 100. Now, how many divisions do I have between the 0 and 20? I have 10 divisions. If you count them, they are 10 divisions. So the value of each marking is 2 meters. This is important so that we can precisely plot our points on the graph. Okay, let's start by plotting the graph. 0 meters 0 meters time 0 seconds. So I plot a point between 0 time and 0 distance. At 2 seconds, the distance was 10 meters. So I plot a point between 2 seconds and 10 meters. At 4 seconds, the distance was 25 meters. Now, as I said before, each grid is 2 meters. So where is 25? This is 22, 24. 25 is in the middle of this grid. So 25 and 4 seconds would be plotted right here. Okay. 6 seconds and 45 meters. 6 seconds on this line, 45, this is 42, 44, 45 in the middle of this grid here. So this is the point plotted between 6 seconds and 45 meters. 8 seconds, 65 meters. 8 seconds and 65. 65 is here as well. So 65 and 8 seconds. 10 seconds and 85. 82, 84, 85 is right here. Remember, using a ruler will help you to exactly plot your point. So 10 seconds and 85 is in the middle of this grid here. 12 seconds and 105. 102, 104, 105 in the middle of this grid. So this is 12 seconds here and 105. Now we need to connect our lines with the ruler in straight, our dots with the ruler in straight lines. Here's our first part of the journey. Now the steepness has changed, it's steeper. The steepness has changed again here. Now if we notice now all the dots are on one line, so it continued with a steady speed from 4 seconds to 12 seconds. So our journey here is divided to 3 parts, 1, 2, and 3. Fast, or let's say steady, but less steep, steeper, and the steepest. Now use your graph to answer these questions. How far did the runner travel in the first 9 seconds? In the first 9 seconds, I need to go back to the graph. I go to 9 seconds. So 9 seconds is here. 9 seconds is right between 8 and 10. I have to raise a line to the graph here. Okay, and see where it's met. On the y-axis. It's exactly at this point here. So if this is 60, this is 70, this is in the middle between 70 and 80, so it's 75 meters. So my answer is, after 9 seconds, in the first 9 seconds, he traveled 75 meters. Okay. How long did the runner take to run the first 50 meters? I also go back to my graph and I go to the y-axis. How long did it take to travel 50 meters? This is 40 meters. This is 50 meters. I drop a line on the graph. Okay, this is the point where it's met on the graph. And I drop a line on the x-axis here. So my point here is exactly in the middle between, this is 7 seconds here. It's exactly in the middle between 6 and 7. So it's 6.5 seconds. So my answer is, for how long did the runner take to run the first 50 meters? 6.5 seconds. How long did the runner take to complete the 100-meter race? How long did it take to complete the 100 meter? Okay, I go back to the y-axis, to the 100 meters. I drop a line on the graph here. Then I drop a line on the x-axis. So my time here is exactly between 11 seconds and 12 seconds, so it's 11.5 seconds. 11.5 seconds. Use the gradient of your graph to determine the runner's average speed between 4 seconds and 10 seconds. On your graph, show the triangle that you use. Remember from the video posted 2 days ago, we said that the gradient, it gives us the measurement of speed, and the gradient is total distance traveled divided by total time traveled. Of course, for the section of the graph or the journey that we are asked to calculate the gradient for. Now, here we want to calculate the gradient or the average speed between 4 seconds and 10 seconds. What do we need to know? We need to know the distance traveled between 4 seconds and 10 seconds. So we go back to the graph. Between 4 seconds and 10 seconds. The distance traveled at 4 seconds is 25 meters. And at 10 seconds, it's 85 meters. So, the distance traveled is the distance between 25 meters and 85 meters. It's met at these points here on the graph. So this line here represents the distance traveled. Okay. And the time is between 4 and 10 seconds. So it's between 4 and 10 seconds here. So this line here represents the distance traveled. The line here is the difference between 25 and 85. So it's the difference between y2 and y1. And the time here is the difference between 10 and 4. Again, so the time traveled is the difference. The time taken is the difference between 10 seconds and 4 seconds. So 10 minus 4, 6. And the distance traveled is the difference between 85 meters and 25 seconds. If you notice here, this is the distance represented by the difference between these 2 points, and the time, that's the difference between these 2 points, is this line here. Now we have a triangle that will help us calculate the gradient. So, gradient is the total distance traveled divided by total time traveled. It equals y2 minus y1 divided by x2 minus x1 equals 85 minus 25 divided by 10 minus 6 equals 60 divided by 4, and the answer is, 10 minus 4, so it's 60 divided by 6, and the answer is 10 meters per second. C. On the graph paper grid below, sketch a distance-time graph for the car whose journey is described here. The car sets off at a slow, steady speed for 20 seconds. Then it moved for 40 seconds at a faster speed. Then it stopped at a traffic light for 20 seconds before setting off again at a slow, steady speed. So here we only have to divide the time axis because we only have data about the time axis. The distance axis, you don't have to divide it or assign any values to it. So time in seconds and distance, let's say in meters. It's not mentioned here. Okay, how are we going to divide our time axis? So 20 seconds, 40 seconds, another 20 seconds, and it goes on. So I have to divide it into 20s. 0, 20, 40, 60, 80, and 100. Okay. Now I need to show the differences in speeds by changing the steepness of the graph lines. I have to read the whole journey to be able to tell which lines are going to be steeper than which. The car sets off at a slow, steady speed. Then it moved at a faster, steady speed. So the first two sections are going to be steady speeds, but the first part is going to be less steep than the second part. So for the first 20 seconds, it traveled at a slow, steady speed. We can show this section of the journey as a straight line sloping upwards, but in a not as steep line as we want. Then it moved for 40 seconds at a faster speed. 40 seconds, so 20 plus 40. Now the time that we need to plot is 60, but the graph line must be steeper. So it's going to travel more distance. So let's say that the line is this steepness here. It's steeper like this. Okay. Then it stopped at a traffic light for 20 seconds. It stopped. This means that it didn't travel any distance for 20 seconds. The line, the graph line now will be flat and horizontal. So from 60 to 80 is 20 seconds. So here's our next point here. Flat, horizontal, straight line. Before setting off again at a slow, steady speed. At a slow, steady speed. So we can draw the line. Also less steep than before, so this represents a slow, steady speed. It didn't say that it's the slowest, so it has to be slower than this part here. The graph represents the motion of a bus for part of a journey. We have a distance time graph. Always look at the labels of the graph. It has two sections. This is the first one, this is the second one. We notice that both sections are represented by straight lines sloping upwards. The first line is steeper than the second line. This is the first step that you need to do whenever you have a graph. Look at the labels, look at the graph lines and see what they represent. On the graph, mark the section of the journey where the bus was moving faster. Okay, as I said before, faster means steeper line. Which section of the journey now is steeper? The first section of the journey is steeper, so this is the faster part of the journey. From the graph, calculate the following. The speed of the bus when it was moving faster. So we already estimated that the first part of the journey is the faster. So the speed of the bus during this part of the journey. Speed equals distance divided by time. The distance traveled in the first part of the journey is from 0 to this point here, which is 700 meters. So the distance traveled is 700 meters divided by the time from 0 to 40 divided by 40, and the answer is 17.5 meters per second. The average speed of the bus. The average speed of the bus means that we need to calculate the average speed of the bus during the whole journey. Okay, we already know that average speed or speed equals total distance divided by total time. The total distance traveled in this journey is from 0 to 1000 meters. So the total distance is 1000 meters divided by the whole total time of the journey, 100 seconds, and the average speed of the journey or of the bus in this journey is 10 meters per second. This is it. I need you to please check your answers. I will provide a clear copy of the answers for you to compare your homework with it. Please correct any mistakes, and thank you very much.